So you just watched a recipe video on making vinaigrettes, and I want to now talk a little bit about the science of um, of vinaigrettes because it's really a wonderful lead-in to think about emulsions. Um, so you can imagine to make a vinaigrette, what you need to do is take some oil and take some vinegar. Typically, it's a 3-to-1 ratio. Maybe add a little bit of salt and pepper, shake them up like in a mason jar, and now you have your vinaigrette. However, that vinaigrette doesn't last forever. If you were to leave it on the counter, you would see over time it would separate. So what's happening there? So let's just draw some sketches to try to understand what's going on. So first, we have our oil and water mixture. And just from the start, this is just, you can imagine just pouring the oil into the water. So the first question you might ask yourself is, why is the oil on top? And the reason why is that oil is less dense than water. So just like wood would float on top of water, but a brick would sink. The oil, which is not as dense, floats on top of water. Okay, now you shake up that mason jar. So you're mixing up your oil and your vinegar. What you're doing is you're creating little droplets of oil, which are now suspended in the vinegar. And a really interesting question to ask here, and you'll see why in a moment, is how does the surface area between the oil and the water change? Basically, have I increased or decreased the number of water molecules that are near oil molecules? So we'll get into that in a little bit. All right, now these oil droplets are still less dense than water, so they begin to cream. They rise up to the top of the surface, and then, over time, they undergo what's called coalescence. So the droplets will actually combine to form larger droplets and larger droplets and larger droplets until you get this solid band of oil now across the top of your liquid. All right, so now we're back to where we started, right? We have some oil and water, we shake it up, create droplets, the droplets cream, then they coalesce, and then we're back to our starting point. All right, so what is happening here, and why does it take energy or work to make a vinaigrette? So it turns out, and this isn't surprising, that oil doesn't want to be near water, right? Oil is hydrophobic. It actually costs energy to force those oil molecules to be near water molecules. Water would rather be around water, oil would rather be around oil. And so when you create a surface where water is touching oil, you're actually storing energy in that surface, as strange as that sounds, and it takes energy to make that surface. Now, where does that energy come from when you make a vinaigrette? Well, it comes from you. It comes from you shaking that mason jar. So when you shake that mason jar, you're putting the energy into the vinaigrette to make all of these little oil droplets suspended in the water, okay? So just to kind of read the box part here, to increase the surface area between the oil and the water, you must put energy into the system. How is this done when making a vinaigrette? Hopefully you know the answer to that. The answer is by the shaking motion or the whisking if you're whisking it. Okay, but you need to put energy in to force the oil to be near the water, to create all those little droplets in the water. Now, an interesting math question, which I will not make you do, but I do want to just talk about the result, is how does the surface area change? And by that I mean, how does the number of oil molecules near water molecules change as you take a large droplet of oil and break it into smaller droplets? So let's assume that we start with something like a 1 centimeter diameter droplet of oil. And the diameter is the distance from one side through the center to the other side. And then we whisk this large droplet of oil into all these small droplets of oil that now have a diameter of 10 microns. Your hair is about 50 microns in diameter, so these droplets are smaller than the width of your hair. Okay, so these are tiny little droplets that we've created. Well, if you were to compare, if you were to take this 1 centimeter diameter droplet and calculate how many little droplets you can create out of it, you would find that you can create 1 billion of these little droplets. And now if you compare the surface area of the two, you would see that you have increased the surface area by 1,000. Right? And that's really the number I want you to take away. You start with a large droplet, and then by whisking it, you create all these smaller droplets that are touching a lot more of the water, the oil molecules, right? So there's a much larger surface area. And as I said earlier, the oil prefer not to be near water. That costs energy to force the oil to be near water. And that energy comes into play when you're shaking or you're whisking the oil into the water. All right. So that's the reason why you have to put in energy into the system, is because you need energy in order to create all of these droplets that are now suspended in water when they'd prefer to coalesce all together and just be this one big droplet. Over time, they go back to that lower energy state, right? So I start with all these small droplets, and if I wait long enough, I just have this band of oil on top to minimize the contact between the oil and the water. And if I have 2 droplets and they combine, that's called coalescing. Now they go to a lower energy state as a single droplet. So these picture here, the picture on the top of the picture on the bottom, just represents a system going from a higher to a lower energy state. All right, so that's a kind of a quick exploration into vinaigrettes and thinking about why do you need to shake that mason jar when making a vinaigrette or whisk it. And we're understanding that it takes energy to suspend all these little oil droplets in water. And so that brings up the question, is there anything we can do to prevent the droplets from coalescing? Now in a vinaigrette, that's not that critical because you can quickly put it on top of a salad, eat your salad, and move on with your life. But if you're making something that's going to last longer, like a mayonnaise, then you don't want all of the oil droplets to just recombine after an hour. You really want them to stay separated. So what can we do? Well, let's look at the recipe for mayonnaise to see if we can get any insights in what might be the key ingredient to help prevent the oil droplets from coalescing. So that will be the next video.